Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all these questions one by one. Students, let us solve the next question. Question number 17. A parallel plate capacitor is made up of two circular plates separated by a distance of 5 mm. So we have two circular plates separated by a distance of 5 mm. So the distance of separation D is 5 mm, which is 5 into 10 raised to minus 3 meter, and with a dielectric constant 2.2 between them. So that is filled with dielectric, and this is filled with dielectric of dielectric constant, that is K value, which is 2.2, and it is obviously a dimensional constant, so it has no dimension or no unit. Where the electric field in the dielectric is this, so the electric field in the medium is 3×10⁴. So there must exist, suppose this is a positive plate and this is a negative plate, so the electric field will exist between the two plates. That electric field is E, and that E value is given as 3×10⁴ volt per meter. Now the charge density of positive plate will be close to, so we are interested in the charge density, that is charge per unit area in the positive plate. Whatever is the charge density over here, the same charge density will be here also, because these two have equal and opposite charge density that is known to us in case of a capacitor. Now, so our aim is to find this sigma. So how to find that sigma? We know that charge density is Q over A, that is charge per unit area. Now the electric field that exists between the two plates and the distance of separation D, they have certain relationship, because if I know the potential difference between the two plates, then again I can use that formula, that electric field is a potential gradient, that V by D. So E is V by D, so V is equal to E into D. So the potential difference is E, that is existing, and D. If I multiply these two together, then I will have a potential difference. Now to find the electric field, because we know that in case of a charge conducting body of any shape, if we have a charge conducting body of any shape, so near a charge conducting body, we have the electric field that exists is sigma upon epsilon, that is the electric field. So this is also a charged body, and in front of it, we know that between the parallel plate capacitors, the electric field that exists is sigma upon epsilon naught. So then I will write then sigma equals to E, and this capital E into epsilon. So this gives you the charge density. So I'll use that relation to get the answer. This is the whole concept, so we'll use that. So basically this sigma will be epsilon into E, whereas this epsilon is nothing but epsilon naught K into E. So these quantities are only multiplied. This is given, and E is given, K is given, epsilon naught is known to us. That is known to us. That is this formula is used to get the answer. So let us put that values over there and see what we're getting. The value for so sigma equation I'll use is E K epsilon naught. E is given as 3×10⁴, K is 2.2, and epsilon is 8.85 10⁻⁻12. That we know, and substituting those values, if I put those values over there, then how much am I getting? The options, if you look at the option, If you look at the option, this is a whole number 3, 6, 3, 6 something and 10 power something. So first we'll look at the 10 power and make it a 1-digit number. So we'll manipulate. Not we're not interested in exact calculations, because you see the options, it is 6, 3. Any number comes out. So this is 10 raised to minus 12. This is 10 raised to 4. So this will be 10 raised to 8 minus 8. So I'll write first 10 raised to minus 8. So these two now gone. This is 2.2. This is 8.8, and this is 3. So in any way, if I take 9, suppose, then this I take 2. 9 to the 18, and 18 3s are 18 3s are how much? It's 60 minus 6, something like that. So 54 something. So this is 54. That means it is 54 or something 60. If you take 60 also no problem. If I take this is 10, this is 2, this is 3, then this is 60, 50. 10, 2, 3, 3 to the 6, 10, then also it is 60. 60 or 54, 54, whatever you get, there is nothing going to change the answer. So these three numbers, if you multiply, I will take this is 3, this number I will take 2, this number I will take 10. So how much I will get? I will get 3 to the 6, and this is 60. 60, 10 is to minus 8. This way you reduce your time for calculation. So this is 6 into 10 is to minus 7, approximately, obviously. And that is the, if you look at the option, then clearly you will have this 6 into 10 is to minus 7, because the order is important. This number, even if you are getting 5.8, that doesn't matter, because the answers are this. So therefore this is coulomb per meter square, because this is the charge density. Charge density is Q by A. Q stands for the charge which is in coulomb. Area of each plate, that is meter square. So therefore coulomb per meter square. So answer is coulomb per meter square. We have already converted that. This distance between two plates is immaterial in this calculations, because we are not interested in this. If you are asked to find the potential difference, then you can multiply this value with this value to get the potential difference between the plates. So if you are asked to find the potential difference between the plates, you multiply E with this number, you will get the answer. Okay. So for this question, the option 1 is the correct answer. 6 10 to minus 7 coulomb per meter square. Okay. Thank you.